First we have to find the critical value, negative t sub 0, for the left tail test of alpha equals 0.01 and n equals 15. So here for this one, as it already states here, you're dealing with a t-distribution instead of a normal distribution. So remember, this one's also in the back of your book or on page 818 in the appendix in the back of your book. So here for this one, if you're looking this up, first of all, if it's a left tail test, that means you're looking at the one tail row up at the top. And then remember for the DF, that stands for degrees of freedom. Degrees of freedom is always n minus 1. So in this case, it'd be 15 minus 1. So your degrees of freedom here is 14. So what you have to do is you have to go to the one tail row there at the top, go over to the 0.01 column, and then go down to your degrees of freedom of 14, where those intersect gives you your critical value there. So if you look that up, you get t sub 0 is equal to 2.624. But here in this case, since it was a left tail test, that means we're dealing with negative ones. So in the table, it only gives the positives, but here, since it's a left tail, we want negative. So just like whenever you're dealing with normal distribution, the t-distribution, remember, is also symmetric. So here in this case, for a critical value, then it would be negative 2.624, using that table for the t-distribution chart. So that's the idea for that type. It's just going through and setting that up. If it helps, you could also go through and sketch it out, that if you're dealing with a left tail, you're dealing with that left-hand side, and that your value here is negative 2.624. That's a way to visually see that as well. And in example 2 here, we're going through a word problem related to this sort of thing. So just something to keep in mind as you're going through and doing this stuff. That for this next one here, we have that the company claims their cans of soup contains at least 12 ounces. You suspect this claim is incorrect, so you collect a sample of 12 cans and find the average weight is 11 ounces with a standard deviation of 0.5 ounces. Is there enough evidence at alpha equals 0.01 to reject the company's claim? And here we need to assume that it's normally distributed. Without that, we cannot use the t-distribution chart, because here the sample size here, if we look at the sample size, it's less than 30, and we're given sample values, so that's why we have to use the t-distribution here. But if you remember from the chart that we had before, that in order to use the t-distribution, we still have to have that the population comes from a normal distribution. Otherwise, we cannot go through and use any type of distribution there at all. So some things to keep in mind there. So once again, write out the null and alternative hypothesis. We're dealing with an average again. So here we have the claim that it's at least 12 inches, so that means greater than or equal to 12 here. And that's the company's claim. That's what we're testing here. Their claim. And then the alternative, remember, has to be the opposite statement. So if that's greater than or equal to, the alternative is less than. And then if we're sketching this out like we've done before, remember this alternative hypothesis is what tells you what type of test this is. So in this case, it'd be a left tail test because we're less than that value. So it doesn't matter which one's the claim, it's always the alternative that you look to for what type of test it is. And to look this up, just like we did in example 1 of this section here, you have to go through and look up your alpha level. So here, alpha is 0.01. And our sample size, here our sample size was 12. So in this case, that would mean then our degrees of freedom, remember, is n minus 1. So our degrees of freedom here would be 11. So if you do 12 minus 1, you get 11 for your degrees of freedom. So whenever you're looking in the table here, we're looking at, it's a one-tail test. That means it's a one-tail because it's left tail. So you go over to the 0.01 column, down to your degrees of freedom of 11, and look to see where those two intersect. And since it's a left tail again, that would mean that we're going to be on the left side of this diagram. We're looking at these values over on the left side here would be the rejection region, like we talked about before whenever we're dealing with the normal distribution. And since it's on the left side, it'll be a negative of the value in the table. So it'd be a negative 2.718 here in this case. So if it's on the left side, it'll be negative. If it's on the right side, it'll be positive. So something to keep in mind there as well whenever you're writing these out. Or if it's a two-tail test, once again, it only gives the positive version. The negative version would just be the same number, but negative instead. So make sure you're keeping an eye on that as you're going through and doing this as well. And then once again here, since our sample size is less than 30, and we're given sample values, the sample standard deviation and the sample mean, that means that we're dealing with a t-distribution. So our t-score, our test statistic here, we go through and do the same sort of thing as what we did for the normal distribution. You do your sample mean minus the population mean over your standard deviation over the square root of n. The only difference here is that it has to be from a sample. It's not going to be from a population standard deviation here. That's why we have s instead of sigma there. So in this case, we'd have 11 minus 12, because 11 was our average from our sample, minus 12, which was our population mean, over our standard deviation here of 0.5 ounces, over the square root of our sample size, which was 12 as well. And then once again, whenever you're calculating this, you want to calculate the top and the bottom, and then divide those two answers. Otherwise, you'd have to put parentheses around the top and the bottom separately if you're going to try and do it all together. So make sure as you're doing this, you plug it into your calculator as well. Make sure that you're getting the same answer here. Make sure, once again, that you're using normal rounding rules to get your values right. So in this case, we have negative 6.93. So that is in our rejection region. Remember, our rejection region is that left side of our critical value. This was our critical value, our t sub 0, or negative t sub 0 here. That's our critical value. So it's less than that value. It's in the rejection region, so that means that we reject our null hypothesis here. And whenever we're testing our claim, we also want to make sure that we're doing our interpretation here. So in terms of the interpretation here, remember our claim this time was the null hypothesis. So if we're doing our interpretation here, if we're rejecting the null hypothesis, we're also rejecting the company's claim here. So here in this case, we reject the company's claim. That the mean here, or that our population mean here, is greater than or equal to 12. at our alpha equals 0.01 level, or something to that effect. The main thing is that you're getting across here that in this case you're rejecting the company's claim, because here we had to reject the null hypothesis. Summary users have in general whether you're rejecting or failing to reject the null hypothesis. And then the interpretation part, remember there's 4 different possibilities. That was in one of your tables here earlier in this unit. So if you need to, go back through and review those. And then you write that out for each of these types of problems.